Hello. In this video, we want to explain to you about the three phase control. So stay with me until the end of this video. Thank you. This device you see is a three phase control. You must connect the three-phase power of the panel control to the RST part on this device. Now we only connected the phase to the R base, which now displays an error on this device because we didn't observe the sequence of phases. At the bottom, there are two 5 amp outputs that can be used for two separate control circuit. That a maximum of 5 amperes can be drawn from this output. You should remove the wire that is in the con- common circuit from the fuse, connect to 50 of this fast control and connect from 80 to start input. I will explain the wiring of this lower part in the next video. There are three LEDs on this device to display this device error, and 5 LEDs are used to set this fast control here. Yeah. Using the third button, you can put on any of the LEDs and increase and decrease the value with these two buttons. Now I want to explain each LEDs. The first LEDs is ambulance. This option displays the maximum asymmetry that can be these phases. That if the voltage of these three phases is asymmetrical, it shouldn't be more than the percentage you specify. If this asymmetry is more than the percentage you specified, it will cut off the fast control of the command circuit. Uh, that according to the motor you have, you can enter different percentage, which can be asymmetric at most 225% and at least 5%. After 5 to 5% to 25%, you can set the asymmetric value. If you set it to 5% at the voltage is more than 5% asymmetric, it, this device will cut off the command circuit. If we set it to 25% and more than 25% of the voltage become asymmetric, this device cut off the command circuit. In the next LED is over, you can set the maximum voltage between 200 and 280 volts with this option. If the network voltage exceeds the value set in this section, the fast control will stop, so the network voltage shouldn't be higher than the value we enter the over section. Uh, that the range between 200 and 280 volts can be considered with this device to network voltage. The under option is the opposite of the over option, and if it is less than this value, it cuts off the common circuit, which is between 310 and 380. If you set it to 310, if the mains voltage drops below 310, the common circuit will cut off. If you set it to 380, if it becomes less than 380, the common circuit will be cut off. In the next LED is for on delay. This on delay option means that if an error occur on the network voltage and it is not resolved after, for example, 10 seconds, disable the common circuit because they are always considering errors on the network. If one error occur on the mains voltage and doesn't resolve after for example 5 seconds, disable the common circuit, which has a time interval between 0 and 10 seconds, so you can set between 0 and 10 seconds. So if you set it to 5 seconds and it doesn't go away after say 5 seconds, disable the command circuit. The next LED is the off delay of time that allows the control circuit to be activated after the fault is clear. You can consider a number between 0 to 600 seconds. If you set it to 0 and after the error is resolved, you can execute the command circuit. If you set it to 610 minutes after the error is resolved, you can run the command circuit. Okay? Uh, there are three LEDs in this bar. If the real LED is active, uh, then everything is okay and the motor can be started. If LED F light up, it shows the error on the power grid. Okay, and if LED P light up, it shows the error on the phase sequence in this part. Okay, that you have to change the place of this fuzzy to fix the P error. In the next video, I will explain more fully about the LED F and P. I will also explain about the wiring. If you have any question about this device, you can ask in the comments. Thank you for watching this video. I hope happy of this video. Bye.